Let's take a look at this problem from the AP Physics EMEC exam from 2012 that covers oscillations. We're given a block of mass 0.3 kilograms on a frictionless table attached to a spring of spring constant K. Alright, so part A asks us to determine the equation for V of t. And so for that, we can just use the equation V of t is equal to V max, or negative V max, sine omega t. And in this case, omega is just 2 pi by your period, and you can get the period from the graph. And for these problems, you just want to remember that the period is just the horizontal distance in repetitions in the graph. So the graph goes up and reaches about 0.7, and so it would just be 2 pi by 0.7, which is equal to 9. Alright, and so now we just have to get Vmax, which is just one of the peaks of the graph. And so it would just be around 0.16. So our answer would be 0.16, negative 0.16 sine 9t. And that would be your answer for part A. Part B asks us to find the equation for x by t, and that would just be the integral of the equation above. So it would just be negative 0.16 sine 9t, and that is just negative 0.16 times negative cosine 9t by 9, and that is equal to about 0.018 cosine 9t. And so this would be our final answer for part B. And now let's clear the board and move on to part C, which asks us to find the value of K. And this can be done in many ways, but we can just use the equation for the period of oscillation for springs. And that is equal to, T is equal to 2 pi square root m divided by K. And so in this case, if you square both sides, you get K is equal to 4 pi squared m divided by t squared. And we solved for t previously, and the mass is 0.3, so it would just be 4 pi squared times 0.3 divided by 0.7 squared. And that will give you a final answer about 24 Newton by meters. And so that'll be your answer for part C. And part D, now we have a friction surface, and we have to determine the forces. So when the block is moving towards equilibrium, we would have normal and gravity. And we would also have friction pointing this way and the spring force, which would be pulling it in the opposite direction. And it would be much longer because the block is actually moving in that direction. And for this one, where it is moving away from equilibrium, we would have normal and gravity. And in this case, the spring and friction would be in the same direction, as friction always opposes motion. And so we would have the spring force and the frictional force. And it would look something like this. And that would be part D complete. And so now let's move on to part E. So for part E, we have to draw a velocity versus time graph. And so it would look something like this. Starts at 0, 0.5, 1, 1.5, and 2. And then we can put v equals 0 right here. You have v here and t right there. And so for this, something important to keep in mind is that it says there is a negligible change in period. And so as our period before was t equals 0.7 seconds, we have to remember that the velocity is 0 when the block stops moving, obviously, and that would be at maximum compression. And so that would be at half the period. So we'll divide this by 2 and we get 0.35. And at every single interval of 0.35, the graph should intersect v equals 0, essentially. And another thing to keep in mind, as there's a rough surface, some of the energy of the system will be transferred due to friction, and so the amplitude should also decrease. And so if this is 0.5, we should have positive increasing velocity, and if this was 0.35, then it should come down and then go all the way down and then come back up at about 0.7 and then decrease again and then hit v equals 0 at around nearing 1-ish, and then it would go back up at around, I would say 1.4. It should intersect this, so it would be around somewhere around like right here, and it should just like continue like that. And as you can see, the amplitudes are decreasing. Drawing's not that great, but at 0.35 it does intersect v equals 0, and at 0.7, which is somewhere around here, it does intersect, and you just have to keep going by that scale, and you should have a pretty reasonable graph to approximate this curve. And this wraps up the 2012 AP Physics C exams problem 1 on oscillations, and thank you for watching.